is exciting. I feel like I'm in space right now. There's something about it that's a very cool vibe. But just to give you a little background about this, so Kate Rubins is one of my closest friends. She and I became friends when John Rinn, who is a near and dear to the Broad family, had been telling me for years and years, you have to know this woman. Why do you not know this person? Why do you not know this person? She's the coolest person in the whole world. And then we were walking down the street, and we ran into her, and he grabbed us and made us meet. And it is true. It is a match made in heaven. Kate is one of the most extraordinary people I've ever met. She's just, when she was at Stanford, all of the people who she worked with said there's nobody who can just work a protocol, control a protocol like she can. She's just a real force of nature. In her PhD work at Stanford, she really developed a lot of their efforts to study Ebola and went and taught herself how to work in a BL4 lab, set up a project in the Congo. And somewhere in the middle, she became a Whitehead Fellow and was having an extraordinary sort of stellar career in science. But the call went out that essentially said, we're looking for a new class of NASA astronauts. And she threw her hat in the ring. And of course, Kate being Kate, made it through. And one of the reasons why she can do that, because it's about, I'm excited, like at one point she's going to come on the screen, but one of the things when they were doing the training, I just kind of always knew, like our friends always knew, of course they're going to pick Kate, because you have to essentially be a triathlete, which she was actually a triathlete, but both mentally and physically, and be able to deal with any situation. And so somebody who can work so flawlessly in a BL4 lab, in a setting in Congo where I think one time she and Stephen Geyer were in a plane that almost crashed, to kind of setting up that type of work, is that she's a force of nature in every way. And it was really exciting. I think it's actually the proudest moment in my life when I got an email from her saying that she wanted to invite me and a +1 to go to the NASA mission control and watch her launch in space. And I was really walking around being like, I'm so proud right now. I'm so excited. My +1 was my 5-year-old nephew, which was kind of awesome. And we got to watch her go. And a lot of folks that are near and dear to her, it was actually a whole scientific conference of folks that came out to watch her go into space. And she's now been there since July, I think. So she's many months in space. She's I believe, 4-month mission. She's kind of on her way back soon, but we're having this opportunity to connect with her. And one of the really amazing things, when I was down there, I was meeting with a lot of the other astronauts who all just kept talking about Kate and what she was bringing, because she's one of the only sort of pure scientists of that background that's coming in and being able to go up in space. And so she's really been bringing this idea, whoa, there you go, of sequencing in space. So,
Houston Station, are you with me?
We are with you.
And I can hear you guys loud and clear from the International Space Station.
Yeah! Woo! Fantastic. Excellent, Kate. This is Broadies. I'm about to start crying. I'm so excited. Honestly. So we have a packed room. I heard you can't hear us, but it's a totally packed room. We're going to take pictures, and you're going to get them later. And we have a bunch of different folks, some folks you know who are going to ask you questions, and some folks from all over, the Whitehead, MIT, from high schools. It's going to be fun. So welcome.
That's fantastic.
Awesome. Great. The first question is from Sean Liu, who's a postdoc at the Whitehead Institute.
Hi. It's very even exciting to stand here to ask you a question. So I just wondering why you choose to perform a sequencing reaction in space, or in another word, so what we can learn by performing sequencing reaction in space. Thank you.
Yeah, that's a great question. And when I first heard about this experiment, I wondered why would you need to do sequencing in space? Why don't we just take the samples up here and send them back down to the Earth? And the answer is we're a much more remote outpost than you would think. So we're orbiting the Earth at 17,500 miles an hour. And we do have cargo vehicles coming and going to the space station, but it's actually incredibly challenging to return samples to Earth. We have a limited amount of cargo down mass. And so the sequencing in space is really doing analysis in situ. It allows us to take samples from astronauts to look at real-time bone deterioration, muscle loss, microbiome of the space station. Any experiment that you want to do in real time, you don't have to wait months and months to get the samples back to Earth. So it's really allowing us to expand the kinds of research we can do up here. More than that, I think in the bigger perspective, we are eventually going to really be leaving low Earth orbit, and we're going to be taking molecular biology tools with us. And the question is, how do these kinds of experiments work when you don't have gravity? So you can see, obviously, this is totally different than the kind of orientation you might be at a lab bench on the planet. And fluidics is different up here, bubbles are different up here, and we're starting to understand how your molecular biology and cellular biology experiments will work in space. And we want to start doing that now as humans start leaving the planet. We want to be prepared to take the entire suite of lab tools with us.
All right. So the next question is so from Sinead Chapman, who's a project manager at the Broad Institute, who's here with her son Cormac, as well as Ronan. Oh, actually, the order. Oh, okay. Do you want to, Jerry's going to go ahead. Sorry about that. We're going to just switch the order. And this, you can't see him, but it's Jerry Fink from the Whitehead Institute. I'm here to ask a question of you. So, yeah.
Hey, Kate, you're missing all the good weather down here. Question is there any effort, you think, to sequence organisms that might have escaped into space from Earth? The space-ome.
Jerry, I love that. I had not heard the space-ome before. I think you might have just coined a new phrase. This is fantastic. Yeah, there's actually a lot of work from the astrobiology folks to understand which organisms might be able to survive in space. If there are organisms that are in space right now, either around the International Space Station, asteroids. People are thinking about sampling on Mars a lot. The question is, how hardy do the organisms need to be? And folks have shown that things like spores actually can survive in the harsh environments of space. We did a couple of spacewalks in the early part of the mission, and I can tell you that being at absolute vacuum with just a spacesuit shell to protect you, I am pretty impressed at any life that can survive at minus 200 degrees and in absolute vacuum. But at the same time, we find life in some really strange places on Earth. So I would not doubt that we're going to see bacteria somewhere besides our planet at some point, or something resembling bacteria.
Great.
Excellent. All right, and now the Cormac and Sinead are back to ask a question.
Hi, Kate. We're really excited for all the work you're doing. The question we had was, what are you finding challenging about sequencing in space, in particular with sample preparation and
Pipetting.
all of the hard things that are difficult on Earth? I'm sure they're even more difficult in space.
Yeah, that's one of the things that I've been working a lot on, and it's not just sequencing. We've actually demonstrated a couple of different real-time PCR machines up here, and that seems a little bit like older technology on Earth, but these are things that we would use for very focused studies, and we're allowed to fly a little bit in our personal allocation. So, of course, I flew some pipetters, and I have been in my spare time looking at how fluids move. And I have actually found that pipetting in space, my hypothesis was it was going to be pretty different, except for small amounts of fluid. It is almost identical to how you would do an experiment on the Earth, and I can show you why. It's the surface tension inside these tubes. So you have, I put just colored water in here. You've got a normal tube, and and I was thinking that the water was going to go everywhere, like it has. It's sort of separated here, and fly out of the tube and cause all kinds of problems. But you do this on-orbit centrifuge. You move the liquid to the bottom, and you can actually open up this conical, if I'm very still about it, and pipette right out of it, and pipette into a 6-well plate, and then hold that plate upside down, because there's no up and there's no down here, and it really stays due to the force of surface tension. So the actual mechanics of doing the experiment are very similar to how they would be on Earth. I think what we're going to find inside this fluid is fascinating, because we're in free fall. I'm in free fall right now. I'm falling along with the station. That does some very bizarre things to physiology, to cells, to fluid. We don't have gravity as a constant in our experiment anymore. And so I think just looking at the basics of cellular and molecular biology in this strange new environment that's off the planet, we're going to find some pretty amazing fundamental discoveries.
Hi, my quick question is, have you or any of your fellow colleagues gotten space sick, and what does it feel like?
You do feel a little bit disoriented when you first launch, and that's because you're going along on the planet, and within 9 minutes you're going 17,500 miles an hour, and this is not something that human beings have ever evolved to handle. The fact that I'm even able to talk to you and feel pretty normal right now, I think, is an amazing testament to human adaptation and physiology. We have not evolved for space travel, yet we're able to adapt to that. So we did feel a little bit not well our first few days, and it's sort of like having a bit of a flu. And after a few days, it starts to feel incredibly normal to float. I talk to folks on the Earth all the time from the wall or the ceiling. This feels like home to me. This is completely normal. It bothers my husband very much when I talk to him from the ceiling, because he says it doesn't look right. So I try to stay in an upright orientation for the Earthlings, because you guys seem to prefer that my head be pointing up.
Great. So then we've got Ryan. Yep. So Ryan is a postdoc at the White House.
Hi, Kate. I'm a huge fan of your work and of NASA and space in general, but most of us are here on Earth, so we were wondering what types of skills that could be mastered on Earth were really useful for you, and were you surprised of something you already knew how to do that has been incredibly useful in space?
Being a scientist and a bench researcher has been incredibly useful in space. I spend most of the hours of my day up here actually doing experiments. We're doing over 200 different experiments for different PIs all over the world. And so just the basic scientific skills has been the most useful thing. The kind of interesting things that I had to learn were how to fly a fighter jet, how to speak Russian, how to do survival training. We have the possibility to land anywhere on the Earth in a quick deorbit, so we do a lot of land and water survival training. We did a lot of water survival training in Russia. We went to the Navy. They put you in a helicopter and simulator and drowned you for a few minutes, and you learn to rescue yourself from all kinds of situations. So that's been, I would say, some of the more slightly extreme parts of astronaut training. But really, fundamentally, what we do up here is research, and being a researcher, I think, has been probably the best training I could have had.
All right. If Allison is still not here, then we're going to go off to some high schoolers who are visiting with us. We've got Miles Wilson, grade 11. Where's Miles? You got your question? Do you want it back, or are you good?
Okay, this is really cool. So when you're not doing experiments, or once you've completed an experiment, what do you do in your spare time?
More experiments.
Awesome.
I do spend some time looking out the window. The planet is beautiful. It's truly amazing. I thought I was pretty prepared for what the planet looks like. You see a lot of photos and videos, and I've worked in mission control for years. They have the Earth up on big screens. There's something about seeing the planet that is completely different from seeing a photograph or seeing a video. It is so much brighter than I expected. And we have some beautiful windows here. There are 7 windows where we can get our whole body and our head into the window. And so sometimes I'll tuck up into the window, and you can get your entire self in the window and just fly over the planet. And I'll do that during a day pass, then a night pass, fly over cities in Europe, fly over the aurora, an entire continent's worth of thunderstorms. So we don't watch a lot of TV up here. We don't really use the internet at all. We mostly watch the planet.
Awesome. All right, and we've got, is it Zenny, is that right? Zenry, a 12th grader at Cambridge, Ringe, and Latin. There you go.
Hello, Kate. All right. Considering that it's an international space station, I'm just curious, like which time zone would you use? Considering that. Yeah.
It's a good question because we have 16 sunrises and sunsets up here. You're in and out of darkness and light every 45 minutes. So how do you know what time zone to use? So we pick a time zone, and we've picked GMT. We've got partner agencies all over the world. So I'm talking to you today from the GEM facility. This is our JAXA module. We have a European module, Russian modules, U.S. modules, a Canadian arm. And so with all of those partner agencies all over the world, GMT is a nice halfway between the U.S. and Russia, works out well for the Europeans. And so we can talk to all of the control centers 24/7 really, but we start our day on GMT time.
All right. So we are I'm going to just ask this one question that Allison Naheen, a research associate at the Broad Institute, asked because it was one of the questions that were chosen. What's the most interesting finding of all your experiments so far in space that is something we wouldn't normally see here on Earth? But that was a great question.
You know, you'd think that I would give you a molecular or cellular biology answer, but the most fascinating thing to me, and I have it here because it's so fascinating, is actually fluids on a macro level. And this is an experiment to look at what happens really to understand fluid dynamics and to start to understand what happens to fluids in a rocket tank. And so you can settle out the liquid here and then give it a different spin and watch the dynamics of the changes. And so it's to me, when I look at fluids or I'm doing pipetting, we're always looking at the milliliter, 10 milliliter, 15 milliliter level. And that's been really fascinating to look at the bubbles and how the fluidics moves. But this macro level of fluids up here has been some of I think the most interesting data, and it just shows how much almost the laws of physics have changed for us. We have gravity as a constant. On Earth, all of this would be at the bottom. Here, it just coats the vessel and then is subject to whatever forces you're giving it. So I think every experiment that we've ever done, with the exception of the few that we've flown in space, have always had gravity pointing down at them. And we take it as a constant. But the fact that we can look at gravity as a variable now, I think is going to lead to some things that just are so different for scientists. And to me, that's usually where we start to make some fundamental research discoveries.
All right. So I'm going to just go down the list because we were just breezing through these questions. Is Keon here? Okay. Bruce Kazumi, are you here? Does that? I guess maybe one of the high schoolers. Do you have a question you want to ask? I have a bunch of great questions. I just don't want to ask them for people. I guess one thing Keon asked was, what do you miss about being a scientist on Earth?
science to do up here. I don't know. I don't really miss too much about the lab bench on the ground. When you put something on the lab bench, it stays there. Up here, you have to Velcro it or tape it down. So I miss a little bit being able to put something down, but I've made a lab bench right outside my crew quarters, stuck Velcro all over it, and that seems to suffice.
And then I think a general question a lot of folks had was just how do we follow your path? What was your path? A lot of folks sort of, and it kind of came late. What kind of preparation would you have for folks in our position that might be interested in doing what you're doing?
Yeah, we just took a round of applications for NASA, and we had about 18,000 people apply. So we're interviewing folks right now, but we're hiring about every 4 years. So look for the next round. And I think that there's not necessarily one path for becoming an astronaut or flying in space. I had assumed I was going to be a researcher on the ground and be a professor eventually. That was sort of my life goal, and what I was working towards until I a little randomly decided to apply for the astronaut program and wound up in low Earth orbit. But I think what you guys decide to do, there's not necessarily one thing to do to be an astronaut. It's whatever you're passionate about. Figure out what you're going to do and do it incredibly well.
Thank you so much. You made everyone's day here, and like I said, it's the proudest moment of my life when you went up in space, and I can't wait to see you when you're back down here. And good luck with the rest of your trip.
Thank you. Thanks. It was wonderful to talk to you all.
Bye. Bye. Now she's just showing off. Thank you all for coming.